Hey guys, what we're going to be looking at is systems of linear equations with three variables. So we're going to go over two examples. These ones are a tad tricky because it's kind of like solving a puzzle. So looking at this example, what we want to do is I have three variables in the first equation and two variables in the second equations. What I want to try to do is figure out how to eliminate some of these variables so I only have one or two after I solve. So looking at this first one, I want to focus on the 2x plus 3y minus z equals 17 and this bottom one, 2x equals z plus 2. And I want to see if I can eliminate some of these variables. So let's look at this then. I want to first stack up the 2x plus 3y minus z equals 17. And I'm going to stack that on top of 2x equals z plus 2. First, I want you guys to notice that I'm stacking up the equal signs, okay? Now let's see what happens. I notice that they both have a positive 2x. If I multiply the bottom one by a negative 2x, this would be, or excuse me, a negative 1. So it'll give me negative 2x minus z, and then this would be a minus 2. Now, when I add these equations, the x's are going to cancel. And I'm going to be left with 3y minus z is equal to negative z plus 15. I'm then going to add z on both sides of the equation sign, and they're going to cancel nice and easy to get 3y equals 15. So then when I divide both sides by 3, I'm going to get y is equal to 5. So that's awesome. I already found one piece of my ordered triple. So instead of an ordered pair, it's called an ordered triple. So you have an x, you have a y, and you have a z. And I just figured out my y value. Now let's see if I can use that information to help me solve any of the other ones. And if I look, it has a y equals negative 3z minus 7. So in red, if I plug that in, it's going to be 5 equals negative 3z minus 7. So I'm going to add 7 on both sides. To get 12 is equal to negative 3, negative 3z, and just divide both sides by negative 3 to get z is equal to negative 4. So we have negative 4. So the last part I'm going to do is I'm going to look at the equations where I have a y and a z where I can solve for x. So in purple, I could use it to in this top one, or excuse me, the bottom one or the top one. The bottom one looks a little easier. That's going to be 2x is equal to negative 4 plus 2. This will give me 2x is equal to negative 2. And when I divide both sides by 2, I'm going to get x is equal to negative 1. Now let's go ahead and look at the next one. This one's a little trickier because all of them have variables. So what we're going to do is we're going to look at compare these two and these two, and we're going to eliminate the same variable. So you can eliminate the x's, you can eliminate the y's, you can eliminate the z's, it doesn't matter, but what we want to do on both of them is eliminate the same variable. I notice that each and every question has at least just one z. So I'm going to use that to solve. I'm going to use that to eliminate the z's first. So I'm going to have x plus y plus z equals 2. And I'm going to have x plus 2y minus z equals negative 3. And I want you to notice when I solve these, let's look what happens. I'm going to eliminate the z's, and then I'm going to have 2x plus 3y is equal to negative 1. So we're going to set that to the side. We're going to come back to it in a second. And now what I'm going to do in red is I'm going to focus on these two equations right here. I'm going to have x plus 2y minus z equals negative 3, and I'm going to also have 2x minus 2y minus z equals 2. And I notice that the z's, remember I eliminated the z's on the first one, so we're going to eliminate the z's in the second one. And I'm going to multiply this by negative 1 in order to change all those signs to get negative 2x plus 2y plus z is equal to negative 2. So now, when I look at this, and I add these two equations up, I'm going to get negative x plus 4y. My z's are going to cancel, and I'm going to have that equal to negative 5. So I'm going to clear up some room here, but what I want you guys to focus on both equations, I eliminated my z values. Now that the z values are all gone, I only have x's and y's in these two equations. So what we're going to do now is treat this like we did previously, and I am going to solve for x's and y's. So I'm going to compare these two, and what I'm going to do is I'm going to multiply this bottom one by positive 2 so I can eliminate the x's. This will give me negative 2x plus 8y is equal to negative 10. And now, when I add up these equations, I'm going to eliminate the x's, and I'm going to have 11y equals negative 11. That means when I divide both sides by 11, y is going to equal negative 1. So, in my order triple, I just found my y first. So I got my x, my y, my z. And now what I'm going to do is I'm going to look back at one of these originals without the x's and the y's crossed out. And I'm going to go ahead and plug in that negative 1y. So I'm going to focus on this top one in red. And I am going to plug in, instead of this negative 1, I'm going to plug in that for y. So that will look like then 2x plus 3 times negative 1 is equal to negative 1. This will give me 2x minus 3 is equal to negative 1. And when I add 3 on both sides, it'll be 2x is equal to 2, which means when I divide both sides by 2, I'm going to get x equals 1. Awesome. So I'm going to go ahead and clean up even more room now because I don't need this anymore. And what I'm going to do is, I already have my x, I already have my y. I'm going to plug that back into one of my original ones. For me personally, the easiest one looks this one to plug in. So my x is 1, my y is negative 1, and then I'm just solving for z. You could have plugged in this 1 and negative 1 for any of these and you would get the same answer. So 1 plus negative 1 is 0, plus z equals 2, which means z just equals 2. So your order triple is 1, negative 1, and 2. If you have any more questions, please feel free to email me or your teacher.